Hello everyone. Today we are going to learn how to assign absolute configuration to chiral center. We will assign R and S configuration to chiral center by using Cahn-Ingold-Prelog rule. So let's see what are the steps. Firstly, you have to identify the chiral center. Means the carbon that is sp3 hybridized and having 4 different groups. Let's see this example where carbon is attached to 4 groups. It is sp3 hybridized, but as you can see, 2 groups are same. 2 hydrogens are present on carbon, so it's not a chiral carbon. We can say it's achiral. Now let's see this example. Here carbon is attached to 4 groups. It is sp3 hybridized and all 4 groups are different. So that means this is a chiral carbon. We can assign R and S configuration only on chiral carbon. In second step, we have to assign priorities 1, 2, 3 and 4 to each of the 4 groups based on the Cahn-Ingold-Prelog priority rules. Now what this rule says that you have to give the highest priority based on the atomic number to the atoms directly attached to the chiral center. That means higher the atomic number of the atom is, the higher priority it will get. In this example, we have 4 groups attached to the chiral carbon: hydrogen, fluoro, bromo and iodo. If we look at the atomic number of iodine, it is 53, bromo 35, fluoro 9 and hydrogen 1. So according to the rule, iodine will get the first priority, bromine will get the second priority, fluorine will get third priority and hydrogen fourth priority. Let's put this number into the structure and let's see where number 4 is. This is your third step. In third step, you have to check where is your lowest priority group is located. In this example, hydrogen is on the back, number 4 group is on the back and pointing away from you. If your number 4 priority group is on the back, then the problem is easy to solve. You don't have to do any extra step. You can go directly to the next step. I will also teach you when your number 4 is not on the back, then what you have to do in the coming examples. So in this case, it's on 4, so we can directly move to the next step. In next step, you have to see how these priority groups are arranged. As you can see that 1, 2, 3, now the number 4 is on the back, so you have to look at these 3 groups, 1, 2 and 3, and as you can see, these 3 groups are arranged clockwise, so we will give the configuration to this chiral carbon as R configuration. R is basically coming from a Latin word rectus, which means right. If this sequence was going anti-clockwise or counterclockwise, then we have to assign the configuration S. I will also take next example that will have S configuration. In this example, let's first assign the priority to the groups attached to the chiral carbon. Iodine will get the first priority based on its atomic number, bromo second, fluoro third, and hydrogen the fourth priority. Now in this example as well, the hydrogen is on the back, which is a fourth priority, so we don't have to do anything, just we have to check the sequence of the numbers. As you can see, the number is going 1, 2, 3 anti-clockwise, and if it's a anti-clockwise or counterclockwise, then we will assign the configuration to this one as S. S is also coming from a Latin word for sinister, or that means left. So this was your S configuration molecule. Now let's see these 2 molecules. These 2 molecules are stereoisomers. The only difference between these 2 molecules is the position of OH and H. In the first example, you have OH facing towards you and hydrogen is on the back. Whereas in the second example, hydrogen is facing towards you and OH is on the back. So let's first try to assign R and S configuration to the first one. We have to look at the groups directly attached to the chiral carbon, and here we have oxygen, carbon, carbon and hydrogen. Oxygen is having highest atomic number, so it will get the first priority. Now we have two carbons. So in this case, when the first atoms is same, you have to move outward atom by atom until a difference is found. So if I go on this side, I have 3 hydrogen, whereas on this carbon, I have 2 hydrogen and 1 carbon. So the next I have carbon, so this group will get the second priority, and this one will be the third priority, and hydrogen will be having fourth priority. Now number 4 is on the back, so I don't have to worry. I have to check how the numbers are moving, clockwise or anti-clockwise. As you can see that it is moving clockwise, so this configuration is a R configuration. Hydrogen is on the back. Now let's see the second example. Again, the priority will remain the same. OH number 1, ethyl number 2, this methyl group as number 3, and hydrogen as number 4. But in this case, number 4 is not on the back. So as I mentioned earlier as well, if number 4 is not on the back, then we have to go one extra step. And for that, what you have to do is first find out the configuration. So let's first find out the configuration. At the moment, number 1 is on the back, so I will go 2, 3 and 4. So 2, 3 and 4 is moving clockwise, so accordingly this is R. But if we look here, number 4 is facing towards you, but the rule says that number 4 should be on the back. Now let's imagine that we are not looking from this side, we are looking from the other side of the paper or the other side of the screen. And from that side, if I will look, then my OH will be on the front and the H will be on the back. In that situation, it will be just the reverse of this configuration. So this is the trick you have to apply, that whenever hydrogen is not on the back or the number 4 is not on the back, it is facing towards you, then whatever configuration you are getting, just reverse that configuration. So if you are getting a R configuration, change it to S. If it is a S, change it to R. At the moment, what we are getting is R configuration, so I will cancel this configuration and write its final configuration as S. So this molecule is having S configuration. Now let's see an example where number 4 is in the plane. That means number 4 is not pointing in. It is not pointing towards you, it is not on the back side, but it is present on the plane. In this situation, we have to follow a swap rule. But before that, let's first assign the priority to the groups. Once we assign the priority, we see that Br is number 1, chloro is number 2, CH3 is number 3, and hydrogen is number 4. Now number 4 is in the plane, so what you have to do, you have to swap it with the group that is on the back. Here we have bromo, so we will swap hydrogen and bromo group. So if we swap it, that means bromo is here and the hydrogen is here. So let's rub this number. Now the priority bromo 1 is here and the hydrogen is on number 4, the hydrogen is on the back. But you have to remember that whenever we do one swap always change the configuration. So whatever you get from here will be the opposite of the actual configuration. So if I look here, at the moment the configuration is coming 1, 2 and 3, that means S, but this is coming up after swapping the group, so that means its original configuration is R configuration. So we have talked about 3 ways to identify. The first one was when the hydrogen is on the back, the second is when the hydrogen is in the front, and this third one example was when the hydrogen is in the plane. We will discuss in next video more examples. I will bring more examples for solving the R and S configurations. Practice with these molecules and practice by yourself as well for R and S configuration, and we will meet in next video. Thank you.